Okay. Any transformed exponential function that's done by vertical shifts and horizontal shifts and vertical stretches and so forth could be written here without the need for a horizontal shift. If you just let B be your base, B could be any number. Okay. Now, if you want to do it for a given value of B, then you got to mess with it some. Okay, and we can do that also. But right now, we're going to just look at this because this is relevant to a lot of what you see on the homework. So, but some of you might have had a little trouble with in the homework. Okay. So, if I give you a graph of an exponential function, and let's say, I'll do it like this. Okay. Let's just say that's a graph of an exponential function. Look, like it's got a pretty good curve. You know, just a freehand sketch, it's not constructed, so don't expect it to be too accurate. Okay. Horizontal asymptote is the line y equals k. If then this graph is shifted down k units, so let's look at this. So this is y equals g of x equals a b of x plus k. And what we want to do is determine from the graph what the values of a, b, and k are. We can do that. Okay. First thing you do is you can identify k if the horizontal asymptote is pretty clear. So if this thing tails off and almost levels off, you're pretty sure that you're close to the horizontal asymptote, right? You can draw a horizontal asymptote. There are other ways to do it, and I could show you how to construct it, but we're not going to take the time to do that. Okay, so we have a horizontal asymptote. And it's at y equals k, so automatically, if we know what the horizontal asymptote is, we know what k is. Well, now I'm going to shift this function down k units. Make all these arrows about the same length. It's a critical length of the arrow. Well, the length of the arrow has to be this distance here. So now we have a graph of plain old y equals a b to the x, because we subtracted k from all the y values. Okay, we shift this graph down k units, then you're going to subtract k from the value, and k is going to be, you're going to get no constant. So this will be the form y equals a b to the x. Okay. Well, now let me just ask you, how can we determine the value of a? That's not completely obvious until it's pointed out, but turns out that the y-intercept is just a, because y-intercept occurs when x equals 0 and b to the 0 is 1, so that when x is 0, y equals a. Okay, so I'm going to make a little note here, the y-intercept. occurs when x equals 0. The y-intercept is at y equals a b to the 0, which is just a. So what's a? Well, right there's a y-intercept, just a little below k. So it wasn't great insight for me to do that, but right here is a horizontal line through the y-intercept. And this horizontal line is the line y equals a. So if we know the scale in this graph, we can just read off the value of a. Okay, now on the homework, there were problems where you were asked to do this, okay? Where you're asked to figure out the equation of the function given the graph, okay? So your first trick is, you know there's a vertical shift. You know that this is asymptotic to the x-axis. So that this has to be asymptotic to y equals k. Well, let me make a note on that because it might not be obvious. I'm seeing some consternation in the expressions around the room. Okay. What I've just written here is the horizontal asymptote to y equals ab to the x is y equals 0. Okay. That's the x-axis. Now, why is that? Well, you know from the construction of the exponential function that as you move to the left, if you construct the basic function, you keep getting closer and closer to 0. And the y value keeps getting closer and closer to 0. So you should be very familiar with the fact the x-axis will be horizontal asymptote from 2 to the x. There's going to be the same for b to the x because you've seen graphs, you've constructed graphs of b to the x for different values of b. They all have y-intercepts. Horizontal asymptotes at the y-axis, and you have these graphs that are going to draw. You have the graph that look like this, and this, this, and some of these I'm actually drawing accidentally touching the y-axis. But we understand these pictures, and we've always got an asymptote. Any one of these curves approaches the x-axis as an asymptote because whatever b is, if b is greater than 1, you take a negative power of b, and you're going to, every time you take a bigger negative power of b, it gets smaller. Okay? And approaches 0 in a way that we should understand. Because for take a calculus course, you're going to want to understand this because it presages the whole concept of limits. Well, I'm digressing all over the place, but explain why this is important, okay? So there's your horizontal asymptote. Now that's something we should know. It's something we should be able to take these pictures. We should be able to construct this picture anytime with various values of b and see in our deepest level of understanding that the x-axis is a horizontal asymptote. And if we multiply by a, that doesn't matter. It's a horizontal asymptote because b to the x can get as small as we wish. So it gets small enough to make a b to the x as small as we wish. And that statement's kind of worth pondering. You probably don't have time to ponder it, but it's worth at least hearing. Okay, so horizontal asymptote is this, and that's the x-axis. So You got y equals ab to the x plus k, y equals k is your horizontal asymptote. So that's why I've written here, horizontal asymptote, y equals k. And that should be obvious both in this picture. If I add k to any of these, they're going to go up k units. So the horizontal asymptote at the x-axis is going to lift up to some k, or go down to some k if k is negative. Okay. So all these things just lift up or go down. And any individual one is lifted up or down, depending whether k is positive or negative. Okay. Too many words, but there it is. Okay, so your horizontal asymptote is y equals k. The y-intercept occurs when x equals 0, and since b to the 0 equals 1, y equals a on the horizontal asymptote. I'm sorry, on the y-intercept. Okay, so you can always then take any exponential function of this form, shift it by negative k, that'll shift the asymptote down to the x-axis, and then you can identify the value of a. Then you want to evaluate b. Okay, well, that's wait. X equals 1, what is y equals ab to the x equal to? Okay, well, if x equals 1, a equals b, ab, y equals ab to the x, which is then just a b to the 1, which is just a times b. And I put a little dot in there to indicate the multiplication, just we don't read that as m. Okay. So that means on the graph, wherever x equals 1 is, let's say x equals 1 is here. I keep stressing, draw these vertical and horizontal lines, so you know what you got. I'm seeing some of them on the test, people getting better at it. And everybody that's taken the test so far has done well. But even people who've done well, I've drawn enough of these horizontal and vertical dotted lines and labeling. Okay, if it's relevant, it should be drawn and labeled. Okay, so anyhow, here's x equals 1. So in terms of the graph, we have this line here where y equals a times b. Okay, so now, if this is the correct graph, how big is a? Show me with your fingers, how big is a? If you go up to the board and put your fingers here. Yeah, show me, okay, and how big is b? Or how big is a times b? Well, a is this big and a times b is this big. Okay, here's a times b. And I can emphasize that by drawing a little vertical line here, or a little vector, a little arrow, and saying that arrow represents a. And where's the arrow that represents a times b? Now, and I could draw it anywhere along this line. Avoid cluttering things up. I'll just draw it over here. Okay, so this arrow represents a times b, right? So how big do you think B is? Okay, so, we did this thing with our fingers. If A was this big and AB was this big, and AB isn't this big, but on the picture, but if it was this big, then reasonably you would expect B to be about what, 1, 2, 3 A's. Takes 3 A's to make B, which means B would be 3 times A. In this case, it looks to me like B is a little more than 2 times A. Okay, so it looks like there's a B, there's an A, there's a B. I'm going to say my estimate, wish I had. Yeah, here we go. Red chalk. Okay, whatever this stuff is. In other words, the A times B arrow is about 2.2 times the arrow. So B is approximately 2.2. Now you can do that with any of the graphs you saw on the homework. And you probably should go back and do it because I'm probably having spent this much time on it.